Buenos días a todos. El trabajo que les voy a mostrar lleva por título Bioprotección.
The work I'm going to present is Bioprotection. The title is Bioprotection and Making Wines Without SO2. This is done by the wine college ICVV with the support of Hansen. I'm going to speak about our research center, the ICVV, which is the Science Institute for the Vine and the Wine. It's in La Grajera, Logroño. It is a farm of 250 hectares, half of them dedicated to winemaking. This institute is a mixed institute by the government of La Rioja, the University of La Rioja, and the CSIC, the Higher Council for Scientific Research, and it was created in 2008. It has a scientific building where we carry out our research activity, an experimental cellar, which is where the tests that I'm going to introduce you to present were carried out, and then the institutional hall and the forum hall. I work with the applied enology and winemaking, and this has the application of biostimulants in the wine to improve the quality of both grape and wine, the assessment of nitrogen content in the system formed by the land, vine, and the grape, and the wine as well, to rationalize its use, and to also the purpose of which is to study alternatives to improve the quality of wine. And we are formed by 2 doctors and 2 interns, and the people that have been carrying out this work is Eva Pilar Alvarez, Dr. Pilar Rubio, and me, together with Dr. Enrique Irribarren. The Institute is celebrating its 10th anniversary this year, and this is why we want to celebrate it with a conference that we are going to celebrate in Logroño from the 7th to the 9th of November. And you can still send your communications or your papers because the date has been extended to the 8th of June. Okay, as we all know, the SO2 is used in winemaking as antiseptic against non-desirable microorganism, as an antioxidant against the negative effects of oxygen. The SO2 also influences on the activity of certain enzymes that cause the losses, such losses of quality of the juices and their derivatives. However, SO2 can affect negatively human health as part of a population is allergic to this compound, and therefore several international organizations like the WHO and the FAO, OIV, have established maximum thresholds for the use of this additive in winemaking and recommending their reduction. There is a concern in the sector, and now alternatives to the use of this additive are being sought after, like high pressures, ultrasound, UV radiation, or high-intensity electrical pulses. As for chemical methods, there is lysozymes, colloidal silver, cytosine, hydroxytyrosol, or extracts of plant extracts. And another alternative could be the use of bioprotector microorganisms that avoid the growth of these indigenous microorganisms that are non-desirable. or avoiding or decreasing the addition of SO2 during winemaking. So the goals are to study the use of microorganisms during fermentation to avoid adding SO2 and assess their effects in the quality of wine through volatile compounds, anthocyans, and organoleptic properties. The materials and methods that have been used. Well, we were using the variety, the Tempranillo variety, which is very important in our area. We harvested manually 400 kilos, and we put those grapes in boxes, and we took them to the experimental cellar of the ICVV. And there we removed pomace or the marc, and then we pressed it and divided into 4 equal batches. Fermentations were done doubled in 100-liter deposits without adding SO2, and 2 deposits were left as control and the 2 others as bioprotection treatment. As for the control group or batch, we inoculated Saccharomyces cerevisiae for the alcoholic fermentation, and the other batch we inoculated lactic bacteria, Lactobacillus plantarum, Viniflora nova, for the maltolactic fermentation. And after 48 hours, we inoculated a non-Saccharomyces yeast, which is Lachea thermotolerans, Viniflora concerto, and the fermentations were done at a controlled temperature of 18 degrees. And daily we measured the temperature and the density, and we also measured malic acid. And 3 times per day we made different measurements and also mixing the mixture to favor the mixture between the must and the pomace or the marc. Once the alcoholic fermentation was finished, wines were pressed to remove the pomace or the marc and the pipes, and we transferred the resulting amount to the 50-liter deposits for the maltic fermentation at 20 degrees. We analyzed the control samples. We inoculated Oenococcus oeni, CH16, and as for the treated, well, that on the control samples, and as for the treated samples, we inoculated the same bacteria 1 day after, as not all malic acid had been consumed. And once the malolactic fermentation was finished, we analyzed the wines, and according to the official OIV methodology determining the alcoholic degree, the pH, total acidity, volatile acidity, tartaric acid, malic acid, lactic acid, alcohol fermentation, IPT, and total anthocyans and tannins. And we analyzed also with GZMS the volatile compounds, and the anthocyans we used HPLC, and we made a comparison with the sensorial analysis of the wines by 12 expert tasters. And we use SPSS and Infostat for the statistical study of results. Fermentation kinetics was faster in the control wines than the ones that were treated, where you can see that the consumption of sugars started after inoculating the non-Saccharomyces yeast. In any case, both wines arrived to the same dryness level. As for the malic consumption, we see that Lactobacillus plantarum consumed malic acid for the first 3 days, and being constant up to 11 days, which is the moment where we inoculated Enococcus oeni bacteria, and we observed how the malic acid was totally consumed. As for the evolution of easily assimilable nitrogen, we see that the consumption was very high in the control fermentation, whereas the one treated by bioprotection had presented no initial consumption of nitrogen, and when the Saccharomyces, then bacteria was inoculated, you can see the graph of the consumption. And here you can see the enological classic parameters, both in the control wine and the bioprotected wine. And you can see that there were no significant differences except for the total acidity and the malic acidity, where the contents were higher in the bioprotected wine. Maybe non-Saccharomyces is a yeast able or capable to producing lactic acid from sugars. But our surprise was that there was not such a reflection in the results. As for the volatile composition, we can see alcohols, esters, and acids, which are the quantitatively more important compounds in a wine. We have to say that bioprotected wine showed higher concentrations of tryptophol, isoamyl acetate, ethyl octanoate, 3-OH butyrate, ethyl butyrate, and 2-phenylethyl acetate. Why this protected wine presented higher concentrations of this? Well, there are studies showing that Lactobacillus plantarum is an organism producing wines with higher aromatic complexity than Oecoccus cocci. And as you can see, and you can know, anthocyanins are responsible for the red color of wines, of red wines, and there are no significant differences. So there were no effects on the color of these red wines. Only one anthocyan showed significant differences, but the concentrations are very similar. As for this sensory analysis, we observed that the bioprotected wines presented a higher aroma intensity, which agrees with chromatographic results of the volatile composition of wines. All of them were assessed as very good according to the scale used, from 40, very deficient, to 100, excellent, and they were having scores of 77. So they were very well valued by the tasters. And as for the smell attributes and the flavor attributes, there were no significant differences, but the bioprotected wines were more fruity, with more acidity and with more lactose notes due to the higher content of the lactic acid in these wines. As for conclusions, we can say that wines made through bioprotection presented a higher content of some volatile compounds than the control wines. We did not see significant differences in color parameters nor in the anthocyans that were studied in depth. And all the wines were very well valued, very highly valued in terms of sensors and or sensorially, and they were having very high aromatic intensity in the bioprotected wines, being considered by the tasters as more fruity and fresher wines. And as a consequence, the use of bioprotector microorganisms, that is lactobacteria of Lactobacillus and non-Saccharomyces yeasts, during fermentations allowed for the elaboration, the making of wines in absence of SO2 with a higher concentration of volatile compounds that improve the aromatic profile of the wines.